Okay, good. So we've got our Feynman rules. I just tidied them up and summarized them there. And we've got the red boxes, which are our 2-point correlation function. We've also drawn the diagrams that contribute to order g to the naught, order g, and order g squared. So what I'm going to do now is I'm going to evaluate each of these diagrams, and I'm going to make sure that, in fact, we reproduce what sits inside the red box. Okay, so let's start off with the order g to the naught. Well, if we look at the order g to the naught diagram, there's a single line. So this will be equal to 1 over alpha because we've got a single line. And then in addition, there's no vertices, so we don't need to worry about a vertex. There is no closed lines. There's no equivalent lines, no equivalent diagrams, no equivalent vertices. So we just get 1 over alpha. Well, looking at phi squared, what is the order g to the naught term? It's 1 over alpha. So indeed, we've gotten the 1 over alpha term correct. Great. And now I'm going to erase this. We don't need this anymore. Very good. Okay, so now let's look at the next two diagrams. Okay, so let's look at this diagram over here. And let's see what this gives us. I just want a little bit of space to work. So let's insert a bit of space and we'll move this down a bit. So if we want to work on this first diagram, so what can we say? So first of all, we need to count how many lines. So let's do that, okay? So there's one line, 1, 2, 3. So this diagram has a total of 3 lines. Because it's got 3 lines, it will have 1 over alpha cubed, okay? Then how many vertices does it have? Well, there is a single vertex on this diagram. So only one vertex. So because there's only one vertex, we will have a minus g times 4 factorial, which I'm going to write as 24. Then, how many closed lines do we have? Well, there's one closed line, there's a second closed line. We get a half for each closed line, so we'll get a half times a half. So let's put that in. So we've got a half times a half. And just so that you remember what that's associated to, that factor over there is from closed lines. Then how many equivalent lines do we have? So how many lines have the same start and end point? Well, that red line starts on the vertex and ends on the vertex. And that gold line starts on the vertex and ends on the vertex. So we've got a total of 2 equivalent lines. So we will have times by 1 over 2 factorial. And this factor is for equivalent lines. Okay. Then how many equivalent diagrams do we have? Well, we don't need to worry about that because we've only got one diagram. How many equivalent vertices do we have? Well, we don't need to worry about that because we've only got one vertex. So what do we land up getting? Well, we've got minus 24g over alpha cubed. And then we've got 1 over 2, 1 over 2, 1 over 2. So that's 1 over 8. 8 goes into 24 3 times, so we get minus 3g over alpha cubed. So for this first term, which is the diagram circled in blue, we've got minus 3g over alpha cubed. Good. Minus 3g over alpha cubed. Oh, let me write that a little bit better. We've got minus 3g over alpha cubed. Great. Now let's look at the second diagram. Okay. So for the second diagram, what do we have? Well, now we're looking at this diagram that I have circled in red. This diagram that I've circled in red. Okay. So what do we have? First of all, how many lines? Well, there's 1, 2, 3 lines in this diagram, okay? 3 lines in the diagram, so we're going to get a 1 over alpha cubed. How many vertices? Well, there's a single vertex, so we're going to get a minus g times 24. Then, how many closed lines? Well, there's 1 closed line, okay? That blue line that I've drawn there. So that's the only line that's closed. So we're going to have 1 over 2, and this is a closed line. How many equivalent lines? Well, none of those lines have the same start and end points. How many equivalent diagrams? There is just one diagram. How many equivalent vertices? Well, there is just one vertex. So if we work out what this is, we've got minus 24 divided by 2 is 12 g over alpha cubed. So the value of this diagram is minus 12g over alpha cubed. If we add these two together, minus 3g over alpha cubed minus 12g over alpha cubed, we'll get minus 15g over alpha cubed. So the two diagrams of order g have given us minus 15g over alpha cubed. If we go back to the red box, well, look at the order g term. It's exactly minus 15g over alpha cubed. So we've got the red term. We've got the order g squared term correct too. The two diagrams that we summed have given us the correct answer. Great. So we've got order g correct. We've got order g to the naught correct. Next, we're going to check order g squared, and we'll continue with that in a moment.